So I can say that lambda 1 is, let me get the pen working again, negative b plus root b squared minus 4ac divided by 2a, and lambda 2 is negative b minus root b squared minus 4ac over 2a. And we have found two solutions for this homogeneous second order differential equation, in fact. So one will be y1 equal to e to the power lambda 1x. Let's change this to x. And y2 equal to e to the power lambda 2x. And the next question will be, are these two the only solutions? Or is there a more general solution for this given second order homogeneous differential equation? In fact, there is a general solution based on y1 and y2 we just found. So it can be shown that if y1 and y2 are the solutions to the differential equation, then y equal to a times y1 plus b times y2 is also a solution. Let's prove it. It's a simple and short proof. Remember, we have this differential equation, a y prime plus b y prime plus c times y is equal to 0. So this is our initial solution, and we assume there are two solutions, y1 and y2 are both solutions to it. So we want to prove that y equal to ay1 plus by2 is also a solution. And this is in fact a much more general solution. So how do we do it? Well, we can just plug in this y into our initial equation. So I'll have, give me a second. A times y double prime. So when I take second order derivative for this y, we're dealing with here, since a and b are constants, so they will stay the same when we take second order derivative, and this y1 will become y1 double prime plus b times y2 double prime. Okay, so that's y double prime plus b times y prime. So similarly, we have y1 prime and y2 prime here, and then plus c times y, which is just ay1 plus by2. If we want to say that this y is also a solution, we have to prove that this expression we just wrote down has to be 0. So is it 0? Well, let's see. Now, I'm going to rearrange these terms in the sum in this way. So you see, here's a term involving a, another term involving a, another term involving a. Let's combine all these terms together, which will give me a y1 double prime plus b a y1 prime plus c a y1, and the rest, let's put them together, plus a b y2 double prime plus b y2 prime plus c capital B y2. What am I going to do next? Well, now I can take out a and capital A and capital B, right? So here I have a y1 double prime plus b y1 prime plus c y1 plus capital B times a y2 double prime plus b y2 prime plus c y2. And if you look at this term closely enough, what does it give us? Well, in fact, if you look back to the original equation, and sub in y1 into it. Since we know y1 is a solution, this term has to be 0. How about the next term? How about this term? Similarly, if you sub in y2 into this equation, you get this sum, which is also 0. And we have actually proved that this whole expression is equal to 0. And this shows that this y is really a general solution to this differential equation that we're dealing with. And this is in fact the general way for us to find out the solution for a second-order homogeneous equation. Okay. Of course, there are other cases. If you still remember, just now we solved this characteristic equation. A lambda squared plus b lambda plus c is equal to 0. And we know that there are two solutions in general. Let me copy it down here. Negative b plus or minus root b squared minus 4ac divided by 2a. According to what we learned in secondary school, there will be three cases, in fact, depending on the values of b squared minus 4ac. So first case is when it's greater than 0. Second case, when it's equal to 0. Third case, when it's less than 0. So in this module, you need to be able to write down the characteristic equation for any given homogeneous second-order differential equation and solve these roots, lambda 1 and lambda 2. And that will tell you which case we're dealing with. So once you find out which case we're dealing with, you can write down your general solution according to this table. So this table is given in the formula card. Please check whether you can find it or not. So the key point in solving second-order homogeneous equation for us is to determine which case we're dealing with.